So we're going to revisit calculus and how it's used in coming up with curve sketches. Now, we've done a lot of curve sketching already, but that's just by looking at basic curves and shifting them and things like that. Now, using calculus, we can find things in a lot more detail. So let's just recap the first derivative, and you may recall our different notations. We could have y dash, f dash x, d dx of the actual function we're differentiating, or probably the most common of them all, the y dx, that sort of thing. It measures, when we're talking about a graph, the slope of a tangent to a curve. I mean, the derivative is, of course, a rate of change, but in a graph, a rate of change is talking about the slope of the curve. So some key things. If we sub a number in and we find that the derivative is positive, then we know the curve must be going up, it's increasing. And if we sub it in and we get a negative number, we know the curve's going down, it's decreasing, and probably the most useful one of them all is if it turns out to be 0, we know the curve's not going up, it's not going down, it's stationary. And that's very useful for finding those turning points. So we're going to sketch a very rough curve, just using the first derivative. 3x squared minus x cubed, so our derivative, 6x minus 3x squared. We can locate our stationary points. Now, again, setting out is key here. Explain what you're doing, don't be lazy. So I found my derivative, so state, why is it now that you're finding the first derivative when it equals 0? Let them know what you're doing. Well, I know stationary points occur when that first derivative is equal to 0. In other words, I want to solve this equation. We get two possibilities, x equals 0 and x equals 2. We know our two stationary points. One is 0, 0, the other is 2, 4. The question also said, or something like determine their nature. So is it what we call a minimum one, so down the bottom, or is it a maximum one up the top? Okay, let's investigate 0, 0, and we'll do this by drawing up a table of values, but instead of investigating the y value, we'll investigate what's happening with the derivative. So 0 is the point we're investigating. We need to pick a point on the left-hand side, and we need to pick a point on the right-hand side. Now you can pick any number you like, but the only rules are don't go past another stationary point and don't cross over an asymptote if there exists one. So 0 we know is stationary. Pick one on the left-hand side. Write down what it is you're picking. I'm picking -1 because I've got no other stationary point on the left. I can pick any number I like. -1 sounds good. Substitute it in, I get -9. I like to draw myself a little tangent to get a feel for what the curve's doing. So okay, that's going down. Pick a number on the right hand side, but I know I can't go past the number 2. 1's a logical one that the pick integers are easier to substitute in. So subbing that in, we get 3, and by drawing in the tangents I get a nice visual representation of what the curve's doing. So that must be a minimum turning point. Okay, let's investigate the other one. 2, 4. So same deal. 2's the one we know, that's a stationary point. I need to pick one on the left-hand side, one on the right-hand side. Well, the left-hand side, I've already picked one because in the other table, we already found out what 1 is. It makes sense to use the same one. Now, a number on the right-hand side of 2, so I just went 3, sub that in, and again, I can see what it's doing. Okay, it's a maximum turning point. It sort of is the logical answer when you look at the y values. I mean, it'd be pretty weird if 0, 0 was the maximum and 2, 4 was the minimum. How on earth could you draw that? I mean, it's a continuous curve. It's no way you can do it. All right, as I say, very rough sketch. We know 0, 0. We know 2, 4. There we go. I haven't bothered finding x-intercepts or anything like that. It's just a very rough sketch. What's the shape doing? Okay.